Wanna join me in proving this interesting result? So over here, the result that's given is we have the sum of all Fibonacci numbers up to infinity, and the sum is like surprisingly negative one, right? So that's the amazing idea. So what's presented over here is basically if I have sum from k equals to 0 to infinity of kth Fibonacci number, this entire sum evaluates negative 1. Yeah, and I will actually prove this in this video. So let me show you how. Okay, so instead of just finding the sum of Fibonacci numbers, I will basically try to find the generating function for Fibonacci number. That means this power series. Sum from k equals 0 to infinity of f kth Fibonacci number times x to the power k. I will first try to find this expression and then we will go on. Proceed forward. Okay, now how do I find this? So let's say the expression is e, or let's say s. The function basically is 0th Fibonacci number x to the power 0, 1th Fibonacci number x, 2nd Fibonacci number x square, 3rd Fibonacci number x cube, 4th Fibonacci number x4, 5th Fibonacci number x5, 6th Fibonacci number f6, and so on up to infinity, right? This is same as the power series actually. And notice that our first Fibonacci number will be 1, second will also be 1, third will be 2, and goes so on, whereas 0th Fibonacci number will be 0. Okay? Yeah. Now, how do I manipulate this sum to get the required expression? I will basically try to use this formula of Fibonacci numbers, that f of n is equals to f of n minus 1 plus f of n minus 2. So for that, what I can do is I can basically try to shift the terms. Let's say if I multiply this sum by x, I get f0x plus f1x square, right? f1x plus x will be f1x square plus f2x cube plus f3x to the power 4 plus f4x to the power 5 plus f5x to the power 6 and so on, right? Now, I'll shift this once more because also later on. Now, if I multiply this original sum by x square, what I will get is f naught x square plus f1x cube plus f2x to the power 4 plus f3x to the power 5 plus f4x to the power 6 and so on, right? Now I will subtract this second and third from the first expression. Yeah, that will give me s times 1 minus x square. So f naught will be as it is, and then f1x minus f naught x. Now over here, notice that over here what happens is, let me show you for one of them. Now over here for this, for this one, what happened was basically we will have x square and f2 minus f1 minus f0, right? But you know that minus f1 minus f0 will be just f2. So f2 minus f2, this is x squared times 0, which is 0, right? So that's why this term collapses. That will just go to 0. You see that? You saw that, right? And you understood as well. This is just the use of the property of Fibonacci numbers. We are just trying to use that to simplify this expression. Yeah? Okay. Now, the similar scenario occurs in this next one too. The similar scenario occurs in this one too. Basically, x cube can be taken out common and f3 minus f2 minus f1 will get cancelled out. Also in this one. And all of them will just get cancelled out. Yeah? So that's why this will just collapse. These others will just collapse actually, and so we need not write these things. Yeah, all of them will just be collapsing, so we need not write these expressions. Okay, now so this is just 0. So now what we can do is we can substitute the values of the Fibonacci numbers. So we have s times 1 minus x square will be equals to, this is 0 plus this is 1 times x, this is 0 times x. So our s is x by 1 minus x square. Therefore, we got that our s was the power series, right? This long power series. So we got that sum from n equals to 0 to infinity of n Fibonacci number times x to the power n is equals to x my 1 minus x square, right? Now after we have got this, what you can do is you can substitute x as 1, right? And if we do that, we get sum from n equals to 0 to infinity of n Fibonacci number 1 to the power n is just 1 by 1 minus 1, that is 1 by minus 1, which is minus 1. Now 1 to the power n is just 1, so sum from n equals to 0 to infinity of n Fibonacci number is negative 1. And that does the proof. Code erat demonstrandum. But wait, like, is that even possible? Can the sum of positive numbers ever be a negative number? I don't know. There might be ways, mathematician might make sense of this in some ways. Maybe there are, but naturally, that should not happen, right? So, if there's wrong conclusion, we should have done something wrong, right? We should have made some errors. So over here, the error that we made is this result is correct, but this result is correct only for certain values of x. This power series does not converge for all values of x over here, and we need to take care of convergence of infinite series. So let's try to find out for which values of x does that series converge. So for that, we will basically use the ratio test. Now to find out for which values of x does this series converge, we will use ratio test. And from ratio test, we know that for it to converge, limit n goes to infinity of n plus 1th term by nth term, this should be less than 1, right? And so limit n goes to infinity, modulus of n plus 1th term is fn plus 1 x to the power n plus 1 divided by fn x to the power n should be less than 1, right? And we know that the ratio of the Fibonacci numbers at infinity is equals to the golden ratio 5 times this is just x is less than 1, right? The modulus of x is less than 1. Therefore, modulus of x should be less than 1 by 5. Now 5 is just root 5 plus 1 by 2. So that will be 2 divided by 1 plus root 5. The inverse will be. Now the value of 2 divided by 1 plus root 5 according to my calculator. Okay, where's my calculator? 2 divide by 1 plus root 5. It's 0.618. Modulus of x should be less than 0.618. So you see, for this series to work, to give correct numbers, to give correct result, the value of x should actually be less than 0.618, right? But over here, we are substituting 1. So that means at 1 the series diverges. And whatever the result it might give, that's just nonsense. Because when a series is diverging, we cannot use any results that were made for the converging values of x. See? So that's why it doesn't really make sense. Though it was fun to prove actually, and to attract you to the video. Yeah. So yeah, always take care of convergence. If you forget about convergence, accidents might happen. You might think you have discovered something new and interesting, but that would be of no use. That would just be a complete waste of time. You see that? Okay, so that was it. Hope you enjoyed this video. Thanks for watching, and I look forward to seeing you in the upcoming videos too.